Hello, I am Akash Vyas, Assistant Professor from Department of Mechanical Engineering, CHARUSAT University of Science and Technology. In present session on a course of metal casting technology, I am going to discuss about a core and core print design used in a sand casting. So basically, you all know that a core is used to create a hollow cavity in a casting, whereas core print is used to provide a support to a core. So while designing a core and a core print, one has to consider the two main criteria. One of it is weight balance. Okay, that means suppose you have a cavity as shown here inside a sand mold, and you need to create a blind horizontal hole. So the core will be of overhang type, and the core and core print can be placed as shown here in yellow color. Now for the weight balance, the basic consideration is that the weight of the core and core print should be approximately equal. Okay, because there may be the chances that due to the downward force, due to the weight of the core and core print, the core may buckle down before the pouring. So to prevent that buckling, the weight of core and core print should be equal. Okay, so here you can see weight of the core body, that is indicated with WB, and the weight of print, that is WP. So WB is less than or equal to WP. So the core and core print are cylindrical in shape. So by multiplying the volume with the density of that sand which is used to create a core and core print, you can get the weight of the body as well as the weight of the print. And by equating these weight equations, you can be able to determine the relation, that is dB square LB is equal to dB square LP, where dB and LB indicates the diameter and length of the core body, whereas dP and LP represents the diameter and length of the core print. And here the row core indicates the density of sand used to create a core and core print. You can also use the core print with the same dimension of core body, but for that you need to create larger mold boxes if you are using the same dimensions. So to reduce that dimensions of mold boxes, we are reducing the length of the print and increasing the diameter of print. So this is the first criteria while you design the core and core print, that the weight of core and core print should be equal. Then the next thing, that is the stress on the mold caused by the core print. So here you can see, for the same case, for the blind horizontal hole, the core is overhang type, and after filling of molten metal, you can see here the red color indicates the filling of cavity with the molten metal. And then due to this molten metal, there may be the buoyancy force in an upward direction. Okay, so here the consideration is that the stress caused by the core print on a mold should be lesser than the compressive strength of the sand mold. Otherwise, there may be the chance that the core print may crush the molding sand, and due to that crushing, there may be the misalignment of core print at the parting line, and due to that there may be the problem to get the desired cavity in the casting. Okay, so how to determine this stress, the crushing stress caused by the core print on the sand mold? So that is the resultant force divided by projected area, that is the stress sigma p. So here basically two forces. One is buoyancy force, that is in upward direction, whereas weight, that is the in a downward direction. Okay, so the resultant force may be either in upward direction or in a downward direction. That depends on the type of metal and the weight of the core that is used. For example, if the core is thinner and you are using the metal that is still having a high density, then there will be the chances that the resultant force will be in upward direction, as the buoyancy force will be in upward direction. But if you are using a thick core, okay, heavier core, and your metal is lighter in a weight, suppose an aluminium, then there may be the chances that the overall resultant force will be in a downward direction. Okay, because the buoyancy force depends upon the density of metal. So you can determine the buoyancy force, that is pi by 4 dB square lb, that is the volume of core body, and the multiplication with the density of metal. Okay, and the total weight, that is the weight force W, that is the weight of the body and the weight of the print. Whereas what is AP, that is the projected area, okay, of the print. So the core and core print are in a cylindrical shape, and if you are taking a projection from the downward direction of a print, so the cylindrical print will be projected in a rectangular shape, and the projected area will be the multiplication of length and diameter, so that is the LP and DP. Okay, so in this way you can identify the stress caused by the core print on a sand mold, and this should be lower than the compressive strength of sand mold. Okay, now if there is another case, if the hole is through type, horizontal through hole. Okay, so here instead of blind hole, suppose there is a through hole, then your core will be like this, and for this type of core you have to provide the print on the both side. Okay, so now in this case, what will be the change in the weight balance criteria? So your consideration is that the weight of the body and weight of the print should be equal. So here you are using two prints, so the total weight of prints should be equal to a weight of the body. Okay, so here the only change will be in this relation that you can see, that is, as we are using two prints, so we can double the weight of core print, and by that you can get the relation dB square LB is equal to 2 times dP square LB. Okay. Then the next, that is for the same horizontal through hole, what will be the change in a stress on a mold? Okay, so here the only change is needed in a projected area. Instead of single print for the through hole, you are using 2 prints. You have to multiply the projected area with 2 times. So that is, in a stress, sigma P is equal to B minus W divided by 2 times of AP. Okay, so in this way you can design if there is a through hole in a horizontal manner. And now the another case, if your hole is in a vertical orientation, either it will be in a blind or a through manner, then you can see, if suppose you have to create a blind vertical hole, then your core and core print placement will be like this. And suppose for the same vertical orientation, if the hole is through, then the placement of core and core print will be like this. Okay, so now there is a question, what changes you need to make for the design of core and core print? So the only change you need to make, that is in a projected area, because now here your print is in a vertical orientation. So by taking the projection from downward direction, instead of rectangular, the projected area will be in a circle. Okay, so you can determine the projected area AP is equal to pi by 4 dP square, where dP is the diameter of print. Okay, so based on, there is one exercise that you have given one cube casting having the dimension of 10 centimeter, and you need to create a hole, that is a blind hole, with the diameter of 3 centimeter and length of 5 centimeter. Okay, so determine the compressive stress on the sand mold caused by the horizontal blind core, assuming core print diameter as 6 centimeter. Check if the mold will fail by crushing. Consider a density of mold core material is 1600 kg per meter cube, and the density of metal, that is here used is a steel, that is 8000 kg per meter cube. Okay, so how to design core and core print for this case? Okay, so here you can see dB is given, that is the diameter of core 3 centimeter, length of the core, that is 5 centimeter. Okay, because you have to create the hole of 3 centimeter diameter and 5 centimeter length, and the diameter of print is given 6 centimeter. So what will be the length of print? So first you have to consider the weight balance, and for that you have to consider that the weight of core body is equal to the weight of core print, and by relating these equations, pi by 4 dB square LB into a density of sand, that is rho sand, with the pi by 4 dP square LB into rho sand. Here by as the rho sand are common, you can get the relation dB square LB is equal to dP square LB. Now you have values of dB, LB and dP, so you can obtain the length of the print, that is LB. Okay, so by putting these values you can get the length of print that is unknown to you. Okay, so LP is equal to 1.25, that is 1.25 centimeter. Now stress caused by the print on a mold, that is sigma P, that is the buoyancy force minus weight force divided by projected area of print. Okay, so first you need to determine the buoyancy force, so that you can obtain by multiplying the volume of core body with the metal density and with the gravitational coefficient. So by putting these values of core diameter, core length, and here the density of steel is 8000 kg per meter cube, and the dimensions are given in centimeters, so converting them in a meter, finally you can get the force of buoyancy, that is 2.78 Newton. Same way, you need to determine the weight, so that is WB plus WP, that is the summation of body weight plus print weight. So we are considering the weight of body and print are equal, so we can calculate the total weight by multiplying the body weight with the, by considering the body weight 2 times, and here you have to consider the density of sand is 1600 kg per meter cube, and you will be able to get the weight, that is 1.10 Newton, 1.10 Newton. After calculating the buoyancy force and weight force, by putting this value you can get the stress. Here the area is LP into dP, so 2.78, that is the buoyancy force, and 1.16 Newton, that is the weight force, and the length of print is 1.25 centimeter, diameter of print is 6 centimeter, and you can get the stress, that is 2.16 kilonewton per meter square. Now this stress should be lower than the compressive stress or compressive strength of the sand mold, and as per the AFS standard, the strength of the sand mold is 50 kilonewton per meter square. So this value is much lesser, so we can consider that the design of the core print is safe. So the reference book is mentioned here, that is the Metal Casting Computer Aided Design and Analysis by B. Ravi. Okay, and if you have any queries, you may contact. Thank you.